Here are two quick examples on multiple ways to write polynomial expressions. The first shows an example written in factored form, and we want to rewrite that polynomial into standard form. The second example shows a polynomial written in standard form, and we will want to rewrite that into factored form. So two different ways to write polynomial expressions. Both of them are extremely helpful in their different ways. But let's go ahead and start with 6.2.1. This will actually be 6.2.2. And we will work these examples in tandem. For the first one, taking a factored polynomial expression and rewriting it into standard form simply means take each of these factors and multiply them out. All right? You can start by either distributing the 2x into here and then taking that product times this factor, or you can multiply these two binomials and then multiply that product by this factor. That's usually the way that I would probably approach it, because I think that multiplying this is a lot less cumbersome than multiplying a monomial, a new binomial pair that would have an a value that is bigger than 1. So I'm actually going to start off by multiplying these two. Multiplication is funny because the order that we multiply does not matter, all right, because of the commutative property. When I multiply these, I get x times x, negative 2 times x, 3 times x, and negative 2 times 3. Combining my like terms, I have this trinomial. This 2x is still on the outside, but what I want to do is distribute that in to every term in here. That gives me 2x to the third power plus 2x squared minus 12x's. And now this polynomial is written in standard form. It's standard form because the lead exponent, the highest exponent, is listed first. All right, and then it's in descending order. So we have 3, a power of 3, a power of 2, and a power of 1. And the 1's not written there, but we know from our Algebra 1 skills that there is an imaginary, it's not an imaginary one, but it's just not shown there. We understand that that's a power of 1. There's no constant here. We may have a constant at the end sometimes. We may have x to the 4th, we may have x to the 5th, and we would have to write those in the correct and corresponding order. This is now a polynomial written in standard form. On this other example, 6.2.2, what we want to do is take our polynomial written in standard form, and we want to find a way to rewrite it in a completely factored form that's going to resemble this form right here. So our first step is to find the GCF. So let's go ahead and do that. The greatest common factor in the coefficients between 9, 6, and negative 3 is going to be a 3. So we know that we're going to want to factor out a 3. Additionally, we have a variable common factor. There's an x to the third, x times x times x. There's an x squared, x times x. And then there's another x here, x to the 1, so that's just x. Each one of these has at least one x, so we can pull that x to the outside. This is going to leave us with, divide each of these terms by 3 x's. This gives us 3x squared plus 2x's minus 1. Make sure that this last term doesn't disappear, all right? We're doing division here. When we factor this out, we're undoing multiplication. So essentially, we're doing division. Our next step is to take this trinomial and factor it, just like we did in our previous chapters. All right, so we're going to end up, once we factor this, it's going to look like these two things right here, except we're going to have an a value that's not 1 for one of them. One of them is going to be 3, and one of them is going to have 3 x's, one of them is going to have 1 x's. So the way that we learn to factor is, what are factors of a times c? So factors of negative 3 that add up to positive 2, that's actually not going to be too terribly difficult. That's going to be 3 x's and negative 1 x's. Group our first two, find the greatest common factor in that pair. Group our last two, what's our greatest common factor in that pair? It turns out that our greatest common factor here is 3 x's. All right, and we will have that as 3 x's times x plus 1. And over here we have a negative 1 as our common factor, and that leaves us with an x plus 1. We're going to factor this from that 3x minus 1. That leaves us with 3x times 3x minus 1 and an x plus 1. This is completely factored, much like the work that we did in our last chapter. But what we did is we took a standard form polynomial and we slowly but surely, step by step, wrote it as a completely factored polynomial. All right, so this actually isn't new for this chapter, but it's an important step to lead us into the next set of examples. Factored form, rewrite it to standard form. Standard form, rewrite it to factored form. You'll need to be able to work those both directions.